All right, everyone, welcome to the part 2 of day 2. Topic 150 interview questions. Leetcode. We are in day 1 where we are trying to solve our first 15 questions. Let's continue that. We had done 5 questions, 5 more were remaining. If you can see over here, 1, 2, 3, 4, 5 done, 5 were remaining. So we were at the rotate array problem and I was facing some issues. So let me do one thing, let me just scrap it out, just reset everything from the start. So I was reading more about it and I found a solution which is pretty decent to understand. Essentially, when we are moving three things to the right, the last k elements will come in the first k. So we want the last k to come to the first. So what we can simply do is if we reverse this entire list from n to n, so the last three will come to the first three, but in the reverse order. I mean, essentially 1, 2, 3, 4, 5, 6, 7. If I reverse it, it will be 7, 6, 5, 4, 3, 2, 1. But this is not what is required. We want to reverse these three as well. So what we're gonna do is we're gonna reverse those 5, 6, 7. Then rest will stay the same. But what happened is these three also should be reversed and are three steps to the right because we have kept three things here. So then we are gonna reverse these four elements. That is n minus k elements. That is 5, 6, 7. It's 1, 2, 3, 4. Pretty simple solution. No issues at all. So we're gonna do reverse of nums dot begin nums dot end. Now what we're gonna do is we're gonna reverse. So the first k elements, then we're gonna reverse n minus 1 elements. So that is plus k. So essentially nums are n nums, and this should solve the problem. And the point is, what if k goes beyond our limits? So we're gonna do k is equal to k modulo nums dot size. Right, and it's gonna submit it. And that's done. Pretty simple, but we need to check mark this so that we can try it out again. Save. I'll write to do so that we can do it again. For now, let's go to the next one. Best time to buy and sell stocks. And to maximize your profit by choosing a single day to buy one stock and choose another day to sell that stock. Hmm. We need to find a local minima and then want to find a maxima, local maxima. And the thing is, we can see the future as well. Utilize that. So we try to sell every day, but let's just try to find the best buy counter with a counter. Int min buy int max. So this is the maximum that the price can go. 0 int n is equal to price dot size. Now while I is less than n, now if a of I is less than min by, then min by is equal to, let's keep int answer a of I. Else answer is equal to max of answer comma a of I minus min by. That's all. I mean, let's just calculate it then and there. Return answer. Obviously a. I plus plus. Okay, best case scenario. Pretty simple question. We're trying to find the local minima and keep finding a better local minima. Now, let's say we are at 6. We found 3 is less than 6, but we need to consider 1 itself and not 3 because 1 is already previous to 3 and it has come before 3, before 6. And we have not seen the future yet. So, yeah, this works out. Pretty simple. Let's go to the next. Same thing. You can decide to buy or sell and an or. You can hold at most one share of the stock at any time. Buy it and then immediately sell it on the same day. So for this, I'm gonna use a technique where I'm gonna try to take every small profit as I can during the week. Say for example, 7 to 1 is not a profit, but 1 to 5 is a profit. Let me cash that out and buy 5 again if required. 5 to 3 is not a profit. 3 to 6 is also a profit. Let me cash that out as well. 6 to 4 is not a profit. So this is the optimal profit maximizing thing for stock market, right? But the thing is, once you have moved to 6, you can't buy it for 3 in real world. But okay. So let's just code it pretty quick. Initially it is 0. So we're gonna go till n minus 1. If a of I plus 1 minus a of I is greater than 0, what we're gonna do is we're gonna do answer plus equal to I plus 1 minus a of I. I plus plus, we're gonna return answer. Yeah. So essentially the crux of this problem was to find the every other profit that we can. So in this case, 1 2 3 4 5, we are cashing out each profit as we go, like 2 to 3, 3 to 4, 4 to 5, and that solves the problem. Next question. How many questions are there? 1 2 3 4 5 6 7 8. Two more questions. Jump and jump, and we're done for the day. Really tired, and I'm gonna go and just sleep off. Given an integer, an initially position of first index, maximum jump length at that position. Okay. So we need to reach the last index. So we can jump two steps from here. So one, two. We can jump one step from here. One. We can jump one step from here. One. But it can be negative and zeros as well. Right. So if we jump three steps from here, one, two, three, we are at zero. We can't do anything for that. So it's a false. So we can reachable is the thing which we can keep a counter of. Now from zeroth position, zero plus two is reachable. Is the maximum that you can reach. You can reach one as well. And if you reach one, then you can jump to right. So is a solution. So simply by now reachable is equal to max of reachable what we can actually reach by now, and then a of I plus I. Now if we can reach n, then it's good, or else bye. If reachable is greater than equal to n minus 1, return true, else return false. Let's just check this. Obviously, my plus plus for 100. I need to get this subscribe thing premium. Let's do see out reachable. We are not reached here. So if you have not reached the position, it's not reachable at all. And I is less than or equal to reachable. Reachable is 0, I is 0. Okay, we can go there. Reachable is 0, I is more than 0, we cannot go there. Done. Simple as it is. So the crux of this problem was to find how much can we reach and keep incrementally increasing the scope of reach for each element. And we need to also check that if we can actually reach that element we are checking or not. And yeah, that's it. Let's move on to the next. Jump game 2. So same thing, but we need to find the minimum number of jumps. Hmm. How are we gonna do this? I can keep a vector of steps required n comma minus 1, let's say. I'm gonna do a here. It is guaranteed to reach n minus 1 for sure. So n minus 1 doesn't matter at all. Let's start from the 0 again. So minimum number of steps required to reach position 2 is 1. So we're gonna do this. One thing is every time you go to each step and check that what is the best steps required to reach there. Or what you can do is let's try reachable method. So plus 2 till here reachable is 2 and number of steps required is 1. Now when we are here this is hmm, max reachable for each step. Okay, we're gonna do two while loops. Okay, a while loop inside a while loop. Now we'll have a counter of number of steps that we can go from each position. Int c is equal to 0, int I is equal to 0. Okay, while I is less than n minus 1 because the last step doesn't matter. We need to find the answer as well. So we're gonna have reachable again. Now reachable is max of reachable comma a of I plus I. Okay. Now what happens is you have a of I steps from here to take. So counter becomes a of I and we're gonna do while c in two steps what is the maximum reachable. We're gonna go every time. So we're gonna do steps of I is equal to count of answer. So while C, okay, all the elements in C can be reached. Answer plus plus. Just for something. Let me just grab. Don't tell me this is right. Now, if let's just do a base case. If n, so let me explain what I just wrote. I is equal to 0, we have 0 position with 0 steps to reach there. Now, when we are at the 0th position, max that we can go is to a of I plus 1, I plus I. That is the reachable time. Now, steps required to reach I is answer, that is 0 steps. Now, C is reachable minus I. And we're going to increase I, and we're going to increase I answer because we need number of steps to reach there. So we are in the second steps, okay. If we're gonna merge this into a single one, Something might not work out. Even if we don't have the steps thing, we're gonna have the answer. We're gonna just come that. Let's just try to submit it. Max reachable 2. Now if C is equal to 0, तब हम करेंगे C is equal to C minus H over. This is to AND C. So we are at the first position. Max visible is 0 plus 1, that is 1. Then we go to this next position. Now C is not 0. We're gonna do C minus minus. So answer is 1. Reachable is 1 plus 2, that is 3. That's out of bounds. Now C is equal to 0, yes. Now C is 3 minus 1. There's 2 more positions we can cover. We need to do answer plus plus. We'll do I plus plus. in third position. We're gonna minus minus. Okay. Sounds first step. A of I is 3, so that is 3. C is not equal to 0. Not done. So let me quickly explain what just happened. Alright. So see, we can't reach anywhere. Answer is 0 steps. We don't need any steps. You don't need this circle. So we don't need to jump anywhere. Now we can't reach anywhere, but we can reach. It is reachable if we take one step. From current position, we can take one more step. Let's take this use case. 3 to 1. Now C is 0. So we need to take one more step because we have not reached the max position yet. Because I is less than minus 1. So we have 3 more slots to go and we have taken one step. I plus plus C minus 1. So because we are taking this step. Again, we are considering what is the max which we can reach from this position in that one step. So from here, two more steps. So 1 plus 2 is 3. Let's say this was by itself 3. Then reachable becomes 4. Okay, so reachable increases exponentially like with C. So let's say all the C's are done. Then we calculate till where did we go? And do we need more steps? And because I is less than n, so we need more steps. So we increment that and we have add more steps to it. C is actually the remaining number of steps that we can take from that current positions without remaining losing any answers. In short. So yeah, and we are done with the top 10 questions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you for watching and see you tomorrow.